All right, we're going to work on review and preview problems, starting with problem 614. Examine the relationships that exist in the diagram at right. Find the measures of A, B, C, and D. Remember that you can find the angles in any order depending on the angle relationships that you use. Okay, so let's zoom in here. All right, so let's just notice some things. We've got two lines here that they tell us are parallel. And we have two different transversals, right? There's a transversal and there's a transversal. All right, so we're going to use those relationships. Let's see, let's start with, let's look at this problem, angle 97 degrees. Oops. There's 97 degrees. And I'm just looking at A here. What is the relationship of A to 97? Well, if I dragged this 97 down the transversal, A would be in the corresponding position. So A is going to be congruent to 97 degrees because those two lines are parallel. Okay, let's look at maybe down here at this angle 112. So I notice together 112 and D make a straight line. Together they are supplementary. So 180 minus 112 is, let's see, 68? Yeah, 68 degrees. So D is going to be 68 degrees. Let's see. So if D is 68 degrees, what is the relationship between D and C? Well, they are interior to those two parallel lines and on alternate sides of the transversal. So C is going to be 68 degrees. And let's see, how do we go? So that leaves me trying to find B. I do notice that B is inside a triangle. So if I knew the other two angles, I could use a triangle sum theorem. So I'm going to look at, try to find this angle right here. I notice two things. That is vertical to D, and it is also corresponding to C. So this is 68 degrees. Okay, so that leaves me with, using the triangle sum theorem, 180 minus 97 minus 68. 180 minus 97 minus 68. I get that B is 15 degrees. All right, let's zoom back out now and look at problem 615. Whoops. Examine the triangles below. For each one, let's see, I'm trying to scroll up. There we go. Solve for X and name which tool you used. Show all work. All right, so let's look at A. We have an angle and a side. We're looking for the other side. This looks like we're going to need to use a trig ratio because 58 is not one of our special angles. All right, so 58 is our angle. 6 is opposite to that, and X is adjacent. So we're going to use tangent. Tangent of 58 equals opposite over adjacent. All right, so now we put in our calculator tangent of 58. And we get 1.6 equals 6 over x. I'm going to put this over 1 and cross multiply to get 1.6x equals 6. I'm going to undo the multiplication by dividing to get that x equals 9.6. That is not right. 6 divided by 1.6, I must have put something wrong, it is 3.75. Again, I noticed that made me feel weird because this angle is going to be like around 30 degrees. It's less than 45, so I know that it's going to be, that side is going to be less than 6. All right, let's look at our triangle B. We know this is a right triangle, and these two markings here tell us that the two sides are equal. That tells us these two angles are equal. This is an isosceles triangle, and those two angles are both 45. This is a special triangle, 45, 45, 90. I know that both of the sides are going to be the same, so I know that that's 7, and the hypotenuse is that number times the square root of 2. Done. All right, in C, I have a triangle. Is this a right triangle? No. I have two sides and an angle. And I am finding the other side. So I am going to have to either use the law of sines or the law of cosines. So let's just think, can I use the law of sines? I have an angle and a side across from it, but I don't have any of the other angles. So I am not going to be able to use the law of cosines, or law of sines. I'm going to have to use the law of cosines. All right, so now I need to label things A, B, and C. This side, the angle that I have is my big C, and this is my little c. My A and B doesn't matter. I'm going to call this A, and I'm going to call this B. All right, so law of cosines tells us that A squared plus B squared, sorry, I'm going to say C squared equals A squared plus B squared. Remember, it starts out just like the Pythagorean theorem, minus 2AB cosine of angle C. All right, so C is what I'm looking for. So that's going to be my x squared equals 15 squared plus 18 squared minus 2 times 15 times 18 times cosine of 32. And remember, putting this in our calculator is tricky. So the first thing I do is type in this big chunk over here into my calculator. So I'm going to get cosine of 32 times 2 times 15 times 18. I have a minus 457.9. So 15 squared plus 18 squared minus 457.9. I get that x squared is 91.1. Whoops, 91.1. And the square root of that is 9.54. Which, yeah, I believe that could be that side length. All right, problem 616. The two shapes at right are similar. Find the value of x, show all work, and then find the area of each shape. Okay, so we're going to use similarity here to find the length of x. What side corresponds to x? Let's see, 10 corresponds to x, and I can choose any of these other sides. Let's choose 12 and 30. Right, so to find x, I'm going to write some ratios. I'm going to say 10 over x equals 12 over 30. Right, so 10 and 12 are both in my small shape, and x and 30 are both in my big one, so they're on the bottom. And now I'm going to cross and multiply. So I'm going to get 12x equals 10 times 30, which is 300. Divide that by 12. And I get that x equals 25. Great. All right, so x equals 25. Now we want to find the area of each shape. Okay, so I think we're going to kind of cut them up into a rectangle and a triangle. And let's see, I'm going to make this a little bit bigger here. The rectangle here is 4 times 10, so this is 40. Let's see, what is the base of this and the height of this triangle? If this whole thing is 10 and this small side is 6, I'm left with a 4. And if this whole thing is 12 and this side is 4, I'm left with 8. Okay, so the area of a triangle is 1/2 base times height, which is going to give me 16. So this area is 40 plus 16, which is 56. So just guess. We know this is going to be bigger. Do you have a guess of what the area of this big shape is going to be? Well, let's see. Okay, 10 times x, we found that this was 25. So 10 times 25 is 250. Let's see, the whole thing here is 25. This is 15, so that leaves me with 10 for the base. The height is 30 minus 10 gives me 20. So 1/2 times base times height is going to give me 200 divided by 2, 100. So 250 plus 100 equals 350. Okay, so our small area is 56. Our big area is 350. All right, problem 617. Graph triangle ABC if they give us those different vertices. So let's just start by doing that. So A is at -2, 7. So there's A. B is at -5, 8. And C is at -3, 1. Okay, so there's our triangle. The first question asks us to reflect ABC across the x-axis to form A prime, B prime, C prime. Okay, so C we're going to reflect here. And C is going to be at -3, -1. A, the x value stays the same. It's going to go down here to, it's going to be at -2, -7. And B is going to be here at -5, -8. So there's our new triangle reflected across the x-axis. Now in part B, it asks us to rotate this new triangle, A prime, B prime, B prime. Oh, sorry, these are primes. Rotate that 180 degrees about the origin to form A double prime, B double prime, C double prime. Okay, so we're going to rotate 180 degrees. Does it matter if it's 180 if we go clockwise or counterclockwise? It does not. So if I rotate C 180 degrees, it's going to end up here at 3, 1. And if I rotate A 180 degrees, it's going to end up here. So this is C double prime. A double prime is at 2, 7. And if I rotate B 180 degrees, it's going to be at 5, 8. Oh, interesting. So then C asks us, describe a single transformation that would change triangle ABC to A double prime, B double prime, C double prime. That looks like a reflection across the y-axis. Okay, problem 618. Earl hates to take out the garbage and to wash the dishes, so he decides to make a deal with his parents. He'll flip a coin once for each chore and will perform the chore if the coin lands on heads. What he doesn't know is that his parents are going to use a weighted coin. That is just like parents, isn't it? That lands on heads 80% of the time. Okay, so that means tails 20%. Okay, so let's make an area model here. So let's see that he's going to flip it for garbage. And he's going to flip it for washing the dishes. And he's going to maybe get heads or tails. And the coin is going to land on heads 80% of the time. And tails the rest of the time, so 20%. What is the probability that he will have to do both chores? So remember, if it lands on heads, he's going to have to do both chores. So let's fill in our area model. 0.8 times 0.8 is 64% of the time it's going to land on heads there. 0.2 times 0.8 is 16% of the time it's going to land here, 16% of the time here, and the rest of the time, 4% of the time, he's not going to have to do either. Okay, so what is the probability that he will have to do both chores? It's going to be 64%. And what is the probability that he will have to take out the garbage, but will not need to wash the dishes? So garbage, heads on garbage, tails on dishes, so that's going to be 16%.